We all experienced the initial magic of vibe coding. You type a casual prompt, and the AI instantly generates a working prototype. It feels incredibly powerful to watch an application assemble itself in seconds. But push that same application to a production environment, where you actually have to maintain uptime requirements and pass security compliance, and that speed disappears into manual debugging. You are left with what developers are now calling AI slop, code that compiles and functions on the surface, but lacks any underlying structural integrity. It skips proper error handling. Hallucinated API calls slip into the logic. And when you ask the AI to fix a bug in one file, it can quietly break 3 existing features in a separate module. You are generating technical debt at light speed. Relying on human oversight to constantly hunt down and manually patch these errors does not save time. It traps you in a cycle where you're spending more time reviewing AI mistakes than you would have spent writing the code ourselves. Moving from writing code to agentic engineering means moving from manual syntax to system design. You are no longer the author of every line. You are the architect of the environment where AI writes it. This outlines the core operational model, replacing casual prompting, the PEV loop: plan, execute, verify. Notice how the plan node expands. Before a single line of code is written, you must define architectural boundaries, constraints, and the roles each agent will play. You cannot orchestrate this kind of complex loop inside a standard chat interface. You need dedicated infrastructure that can manage state and pass data between different models. This is why you must eventually commit to a multi-agent orchestration framework, like CrewAI, LangGraph, or AutoGen. Every single one of them requires months of specialized learning to master. Because these frameworks create deep architectural lock-in, your initial choice determines exactly where your scaling bottlenecks will appear 6 months from now. Let's start with CrewAI. Its core architectural philosophy is simple. It directly mimics a human organizational structure. In this org chart, you must explicitly define your agents. Give this researcher node a role, goal, and backstory, and do the same for the writer. Execution flows via sequential handoffs. The researcher finishes its task and passes the data payload directly to the writer. Because this maps so closely to how we already work, the setup is highly intuitive. You can rapidly deploy standard business workflows with minimal friction. The critical trade-off is control. CrewAI lacks granular precision and struggles significantly when your application requires complex, non-linear conditional logic. If you want rapid, out-of-the-box team collaboration and are willing to sacrifice extreme architectural flexibility, CrewAI is your choice. On the other end of the spectrum is LangGraph. This is your solution for strict structural architecture and state management. To use LangGraph, you physically build intricate graphs with specific nodes, connecting edges, and rigid logic gates. It excels at precise state persistence. If data fails a condition at a gate, the system routes it backward, retaining its exact memory state. This yields massive scalability. It provides the bulletproof, predictable execution you absolutely need for enterprise-grade production systems. The trade-off is a steep curve. It doesn't feel like prompting. It feels like traditional software engineering. Applying this level of rigorous architecture to simple, linear automations is simply a complete waste of your resources. LangGraph forces you to trade initial development velocity for absolute deterministic control over complex, mission-critical systems. Then there is AutoGen. It abandons rigid pipelines entirely, building its framework around dynamic, multi-agent conversations. Here, you establish a chat environment. You define user proxies and agents around a central, open conversational hub to facilitate natural language problem-solving. Instead of following strict edges, the agents use natural language to iteratively critique, brainstorm, and refine solutions together. This provides unmatched flexibility for open-ended problem-solving. It also allows for seamless human-in-the-loop intervention, meaning you can step into the chat and guide the agents at any stage. The major trade-off is conversational drift. Relying on free-flowing chat makes your outputs inherently less structured and much less predictable than strict state machine graphs. AutoGen prioritizes creative, fluid iteration over structural predictability. You must actively manage the system to prevent agents from getting stuck in endless, unproductive chat loops. So, how do you decide? You must map your primary goal directly to the correct framework. This decision tree breaks down the paths. If you are an enterprise architect, LangGraph is your mandatory choice. Its high training cost pays off by yielding a truly scalable state machine. If you are an automation builder or a startup founder, CrewAI is your match for deploying sequential business tasks without rebuilding the wheel. And if you are a prototyper or researcher, AutoGen fits your need for iterative, human-supervised exploration and fluid problem-solving. Achieving a positive ROI on the hours you spend learning requires choosing the framework that exactly matches your project's tolerance for architectural complexity. A casual prompt is now just a single input in a larger system, not a replacement for engineering. The actual job of software engineering hasn't disappeared. The medium has simply changed from writing syntax to orchestrating logic. The 2026 engineer is a system designer. You are building the constraints that allow AI agents to work safely and effectively. If you stop writing code manually and start building these orchestration loops, you change the scale of what you can ship. The teams that master these agentic engineering frameworks will be the ones capable of shipping at a volume that traditional hand coding simply cannot match.